Welcome to lesson 4.1 and 4.2. I have already pre-filled in all of the exponent rules that you need to know for this year. So what I advise you to do is pause the video right now and copy down all of these rules, and then when you are done copying it down, unpause it, and I'm going to talk through just a few of them. Not all of them, but there are a few that I want to say some particular things for. Okay, so now that you've copied down all of these rules, I really want to point out a few of them. The first one is this one here, the a to the m over n. Whenever the exponent is written in a fraction form, you just need to know that the top number is the power that you're raising your base to, and the bottom number is the root that you're taking. So like if this were a 3, that would be the cube root. So you would take the third root or the cube root of whatever number is right here. And then the top is what power you're raising it to. So if this were like a 2, then you would square this number. So you should probably go in this order of doing the power first and then rooting. It just might be a little easier. So you're going to take whatever the base is, raise it to that power, and then you're going to take this root, whatever that number is. It could be the 4th root, the 5th root, the 10th root. Your calculator will do it for you. The next one I really want to point out is kind of both of these ones here with the negative exponents. So if you recall, to make a negative exponent positive, you simply switch the side of the fraction that your base is on. And what I mean by the side of the fraction is if it's in the numerator spot, it moves to the denominator, and if it's in the denominator, it moves up to the numerator. And once you do that, it then becomes a positive exponent. So you'll notice for this example, x had a negative exponent, so I moved him from the numerator down to the denominator, and it became positive. Same thing for the y. He was in the denominator spot, so I moved him up to the numerator spot, and he became positive. Now, if one of them had a positive exponent, you don't move it. It stays where it is if it's positive. Also, if there were a number out in front of the variable, like if there was a 3 out in front of this x, the 3 does not move because the 3 imaginary exponent is a positive 1. Only the thing that has a negative exponent directly attached to it moves. So same thing here. And if when you move your base from the numerator to the denominator, if there's nothing left on top, there's an imaginary 1. Same thing if there's nothing left on the bottom, there's an imaginary 1. And I think that's all. Last one. Anything to the 0 is 1. Anything. Any number in the world to the 0 power is 1. And I will show you in class an example of why that is. And you do need the rule right below it to understand why this is 1. So in class, I will show you an example and make sure you understand this one because that's what we're going to need to prove why anything to the 0 is 1. So when you're dividing two bases that are the same, you can just subtract their exponents. Okay, so we're going to do a few examples and then we're done with this video and this lesson. So for some reason when this printed, these boxes showed up instead of, they were times signs. So make those into like big dots. This multiplication. Okay, so the first one, all of the bases are the same. They are all 2's, which means we can combine all 3 of them into one base of 2 by doing something special to the exponents. When you are multiplying, you add the exponents together. So 3 plus 4 is 7 plus 0 is 7. So that becomes 2 to the 7th, and that's how you leave your answer. So again, you can only combine the ones that have the same bases. If there was one that had a different base, okay, fire alarm. So the next example, example 2, requires us to solve for the exponent n. We are trying to figure out what number could go in for n so that when I raise 3 to that number, I get 1/9. Well, we know that 3 to the 2nd is 9. But I want 1/9. I want the 9 to be on the bottom. And using our rules up here, we know that if the exponent is negative, it will move from the numerator down to the denominator or vice versa. So if I make this a negative 2, that would mean that it would become 1 over 3 squared, which is 1 over 9, which is what I wanted. So that means that n, the exponent, has to be negative 2. So if the number, like 3 squared is 9, we know what we need to raise 3 to get this number, but it's just not in the right spot on the fraction. So we just had to change the sign. Example 3. We have a single base of 3, but we are raising it to 2 exponents. First we're raising it to the 4th, then we're raising it to the negative 2nd. You could sit here and figure out what that is, but we just want to use our exponent rules to make this into a single exponent. So our exponent rules when we have a power to a power is to multiply those exponents. So that is negative 8. There's your answer, but we should never leave our answer with a negative exponent. So what I'm going to do is I'm just going to move the 3, because it's raised to a negative 8, to the bottom, since it's on the top, to become a positive 8. And then since there's nothing left on top, there's an imaginary 1. The next one, actually the next 3, I think are brand new. You've never seen ones with fractional exponents before. So this one, if you recall, fractional exponents, the top means power, the bottom means root. So first, I'm going to rewrite it. The base goes under the root, and the power is to the first. The root is to the second. Now, the second is the only one that you don't actually have to write the number in the root spot, because if there is no number, there is an imaginary 2 there. But I'm going to write it there just so you can see what I mean. This is the same as just writing the square root of 100 to the first, which technically we don't write that either. There's always an imaginary 1 there if there's nothing there. So technically, I could rewrite this as just the square root of 100, which is 10. So that's your final answer. The next one, before I begin, I have to take care of the fact that there's a negative with my exponent. So I have to move 32 to the bottom, and then it becomes a positive 1/2. Now I'm going to turn the 32 to the 1/2 into the power root form. So this is 1 over, this is the root, square root, second root, and the power is 1. So that's 32 to the first, which is just 32. There's your answer. The only thing is you have to simplify this radical. You learned that last year in geometry. There are a couple ways to simplify radicals. I will go over them in class, but what my favorite way is just to find the largest perfect square that divides into 32, and that is 16. So if I break this down into the square root of 16 times the square root of 2, then I'm going to take the square root of 16 because it's a perfect square. It's 4. So this turns into the number 4. So my final answer is 1 divided by 4 times the square root of 2, or 4 radical 2. Last example, 16 to the 3/4. There's no negative exponents. I don't have to worry about making it positive. I can simply rewrite this with my power and my root. So this is 16 to the 3rd power, and we're taking the 4th root. Now I told you you should probably do, it really doesn't matter which one you do first, but I always like to work inside first. So 16 to the 3rd, that is 16 times 16 times 16, that's 4,096. Now you're going to take the 4th root of it. Basically what you're doing, and what your calculator is doing, is it is finding what number times itself 4 times gives you 4,096. Now you can use your calculator to do this. If you don't know how to do it on the calculator, I will show you in class, or you can see me. But you want to basically look for the root button, and you want to put a 4 in the root spot. Turns out it's 8. 8 times 8 times 8 times 8 would give you 4,096. And that is it for lesson 4.1 and 4.2.